you have to find out the transient response. First of all, find out the transfer function of the whole system. Remember, please be careful. Whenever, you see in this case, it is, the feedback is h, transfer function is h for. If nothing is given, then it's 1. You assume its value is 1. So this is 1 basically. If nothing is given, assume it's 1. Now find the transfer function by using this formula. By using this formula. So please do that. So find transfer function by using that formula. So find Ts equal, write down this formula and simplify it. Simplify it. So you have a system in which there is a feedback. Use that system and then simplify it. So it will be what you will write. What you will write. What will be the transfer function?
1 over 1 plus g.
Everybody should answer. Everybody should respond. So it is like this. G over 1 plus gh. What is our g? 12 over s plus 1 s plus 9 over 1 plus the product of these two. So 12 over s plus 1 s plus 9 multiplied by 1. Right? This is exactly what you have seen here. Now you can simplify it. If you take LCM, you will get 12 over s plus 1 s plus 9 plus 12, and that LCM will be cancelled out from the denominator and numerator. Then this is your, basically your C over R. So your CS over R is this one. Well, we have now a very nice example where we have a system in which there was a feedback, and he wants us to find out the transient response of this closed loop system. And the transfer function of the system is given. And the feedback was given. But we assume the feedback is 1 because no transfer function was given. So the transfer function of it will be g over 1 plus gh. Now you solve it, take LCM, multiply it with this. LCM denominator will cancel, you get this one. So C over R is basically, this is your transfer function. So you simplify it. C is equal to, so you have s plus 1, s plus 9 plus 12 multiplied by C equal to 12R. You can simplify it. It will be s squared plus 10s and plus 9 plus 12 equal to 21. And this is your C equal to 12R. Is there any difficulty here? I don't see any difficulty. I don't see any problem here. These steps are clear? I go back so that you don't have any confusion. This was a system This is the response of our system. C, R, output, input, feedback. What is the transient response of this system? We want to find out how this system is behaving as a function of time. That's the question. What we did, we first of all find the overall transfer function. Because they are in parallel, if nothing is given, it's 1. Then you use the parallel formula, G over 1 plus GH. G over 1 plus GH. Simplify, SC over R. Cross multiplication, you get this C equal to 12R, S square plus 10S plus 9 plus 12, 21. Now I end up with this equation. Now, what is S square? I wrote big equation today. The S square, if you take a Laplace on each side, right, remember what it should be. It should be, what was our function? So S square should be basically S square C minus S function at 0 minus derivative at 0 plus 10S, it should be 10S function minus function at 0. Then you have 21 and it should be just a function. And this whole thing, the same thing I have done, is equal to 12R. Conditions are given. Initial condition C0 is 1 and C dash 0 is 0. So this is done, this is 0, and the rest of it we will get S square C minus S plus 10, and then you have SC minus 1 plus 21C equal 12R. Take C common from throughout. So you will have here your, by assuming this is given. For this question it is given. Also given is that 12R is 0. This is also given. It cannot, maybe it's 0, maybe it's not. So you will have S square C minus 10SC minus S plus 21C minus 10 equal to 0. It's a simplifying algebraic equation. Then put C